Hi, I'm Philippe Alamy, and I will speak today in my name, in the name of my company, a very small research and development enterprise dedicated to energy modeling, simulation, and BIM. I will speak also in the name of BIPV Boost, a H2020 project dedicated to BIPV with a large consortium of specialists. We authors are leading the digital innovation work package, focused on developing the next generation of BIM-based BIPV software platform. I want to thank my European colleagues for supporting this exciting adventure. Our joint focus is simple but complex. We wish to see architects, engineers, BIPV experts, building contractors, and manufacturers committed to create bankable building skins. Our challenge is the following. First, support BIPV adoption using BIM maturity today, because BIPV is a perfect perspective for BIM. Collaboration, integration, cost reduction. Second challenging effort is project digitization towards BIPV solutions within a reference workflow, enabling risk mitigation. Third defined, we aim at addressing the nearly zero energy building market and positive energy building market under the related European directive and national regulations. Why BIM? BIM stands for Building Information Modeling, mainly based on a digital model of the building project. But BIM is also a lot of management and methodology to process every construction project during its whole life cycle. I would say that 3D modeling and 3D visualization mean that the more you see, the better you know about the project. Therefore, the better every stakeholder is committed to informing and deciding about the project hotspots, avoiding bottleneck effects. Our ambition is to cover the whole value chain with BIM for BIPV, from pre-design to construction, but also to building operation and maintenance. That means working at the same time at element and building levels, using BIM technologies, optimization methodologies, and embedding manufacturing. Is BIM a driver to reduce BIPV costs? Can we develop a BIM for BIPV strategy to boost BIPV on the market? This is our vision. The reference BIPV workflow highlights the need of a strong commitment and decision support from the earliest stages of the project. Impact of decisions is very high in terms of risks and costs. Complexity suggests innovation and high risk mitigation. The main decisions must be taken between conceptual design and preliminary design. The architect transfers a complete set of requirements to the experts. The trade-off between materials, building shape, and bankability highlights the need of additional information, specifications, and simulations. BIM is seen as the provider of reliable and collaborative data, such as CAPEX, enabling interoperability between design and manufacturing, generating extra cost-based KPIs. BIM is like an iceberg. Beyond the visible part, BIPV addresses the hidden part, considering multidisciplinary issues, lots of techniques and analysis, together with a high level of coordination and mutation of practices. The typical McLeamy curve from BIM benefits fits perfectly well with BIPV. The cost of design changes is mitigated by the power of generating reliable data and several options at the earliest stages of the design process, keeping also the best flexibility. Like a renovation tells its stakeholders, focusing on use cases drives best user stories, roadmaps, and brings a lot of perspective. In this roofing case from Schweizer, the complexity comes from the mounting system and the module's layout. The CIGS module is very simple by itself. BIM should enable the coupling of building design, roof structure, and mounting systems together with energy simulation and economic studies. Lots of information, several tools, risk of overcost, one solution, integration. In this ventilated facade case from Verden, Onyx and Tulips, the complexity comes also from the mounting system and the module's layout, but also from the module design and its manufacturability. BIM should enable the coupling of module, manufacturing and installation together with energy simulation and economic studies. The role of virtual components is crucial. They should be multifunctional, scalable, and easy to use with a scope covering material to system. We defined a comprehensive digital adoption plan dealing with materials, preliminary significance of modules with intrinsic parameters called macrotypes of BIPV systems, and related to level of information and level of geometry, leading to BIM standardized levels of details. Our main issue is the coupling simulation workspace and architectural design CAD, regardless of products and projects complexity. Time spent in studies, delays. This is not a great discovery, but the main reachable source of savings for BIPV design. Here is our roadmap. Development of families of BIPV BIM objects within comprehensive architecture, engineering, and construction workflow, disseminating our innovation to the largest community of BIM users. We chose to address the Autodesk BIM Revit solution, first because of its powerful workflow with families of BIM-ready objects. Our program, our findings, a target name BIMsolar, unique solution dedicated to solar architecture, BIPV and BIM, supported by InnoEnergy and the H2020 programs. Our BIM and cost reduction roadmap is very ambitious and requires several years of development to bring well-known industrial innovations to BIPV. Digital thread for product management, digital twin for system management. They are the foundations behind a digital transformation. Data, information remain the main assets for sure. Here is our today's state of the art. We developed two BIM add-ins for Autodesk Revit. They complement the interoperability between BIMsolar and Revit. First, the architectural design is exported from the CAD, Revit, to BIMsolar. Geometry is analyzed and translated into the simulation workspace. Then, BIMsolar enables feasibility studies, BIPV design of modules, strings, inverter selection within a contextual workflow. Finally, the second add-in re-imports the complete solution into Revit. The BIM and active building skin are born. What is BIMsolar? The desktop software reflects contextual design for BIPV, starting with 3D distribution of irradiance, mapping solar irradiation on every single surface, sharing direct, diffuse, and reflected gains. Then, BIMsolar enables design of modules, from grid of macrotype to array of complex glazing systems. Technical studies are completed with string strategies, selection and setup of inverters with MPPTs. Results are displayed in live view. What-if analysis is the first step before more sophisticated optimization processes. BIM is enriched with the share of data collection between element and module level. BIPV systems are exported to the BIM Revit master solution. Optimization processes. Dealing with several design variables, responses given by the BIMsolar computation, the Pareto frontier methodology generates best trade-off solutions related to cost and energy generation. Here is our feedback from real demo cases. Here is a full insulated facade renovated with glass opaque BIPV from Onyx Solar, the PV Sites project. BIM model for the residential building, BIM modules, now available to public users. The rear facade with temporary dummy elements. Here is a full insulated roof renovated with CIGA tiles from Philippe PV sites project. BIM model for the single house BIM modules, now available to public users. Here is the real roof, validated design and validated cost savings. Our conclusion: we are supporting BIPV cost reduction with BIM. With this strong focus, we anticipate incremental costs, so we can expect 5% of immediate gains, up to 15% if we can merge BIM and manufacturing of BIPV systems. This is a long-term research, development and innovation investment. Thanks to the H2020 European Programme, BIPV Boost Consortium and all our partners. Thank you very much for your interest, and now it's time for questions.